All right, well, welcome back, everybody. What we want to do today is solve some larger systems of equations. We kind of previewed yesterday how to solve more of a basic x and y system, but what if you have like x, y, and z? Okay, well, this year in Honors Trig Pre-Calculus, we want to be able to make short work of these. We want to be able to get these right with fidelity. In other words, this is not a bonus question anymore. So I call these mega systems basically just a larger system. And the idea here is you're going to try to combine and cancel and turn this thing into two variable equations. Again, the idea here is you're going to end up creating two variable equations, but you're going to want two of these because those are the kind that we solved yesterday. So if you look at this system that I started with on that first slide, it's got x, y, and z. And let's get to the business of trying to turn this thing into just x and y, trying to turn this into just two variables. Now, if you look at equation 1 and equation 2, it should catch your attention that the z's are opposites. Now, if you have opposites, just like yesterday, you can use like an elimination method. You can add those two equations together. Now, if I add the equations together, the x, it's not going to really add to anything, but of course I still get x. If I add the y's together, now I have 3 y's, but it's the z's, when you add those together, they will cancel. Now, don't forget to add your constants. Honestly, that's often where the mistake is made. People either forget to add them, change them, but we're going to end up with 7. Now, what do we have? Well, we have a new equation that has two variables. But look, there was already this third equation that had two variables, and of course, they are the same two variables. In other words, we've just made for ourselves a smaller, simpler system, something that we can solve using yesterday's techniques. And it would be my recommendation that you would make some opposites happen, namely make the 3 y's be opposite. But of course, if you're going to multiply by -1, you got to multiply everything by -1. So we're going to continue the business of solving this. Of course, when you add your x's, 2x and -x is just x. Your y's are going to cancel. Your constants, your numbers, x equals 4. And once we get x equals 4, we're kind of on our way to finding the rest of y and z. Now, remember, you don't want to plug back in to the original equations. Why don't we plug back into the smaller one that we're working with here? And I know that you can do this. I just want to make sure that you know what I'm doing. I'm plugging back in, solving this thing for y equals 1. Once I get y to equal 1, of course, I already had x equaling 4. Then you can plug back into one of the original equations. Perhaps you choose to plug into the top equation, but you could also plug into the second equation because we're just trying to find z. I'm going to plug into the top equation x plus y minus z. So that would be 4 plus 1 minus z, which I'm looking for, equals 8. So that looks like z has to equal -3. When you write your answer, it's not an ordered pair, but an ordered triple, or sometimes called a triplet. So we can still write it as x, y, z. Kind of easy, right, when you're following the teacher. But what happens if the mega system just got a little bit more mega? What if all the equations have x, y, and z? Well, take your time, first of all, and copy this down. If I could mention nicely, when you are doing these problems, make sure you can read your handwriting. One of the common mistakes I see is that students are unable to differentiate between a z, which I will always mark with a line in the middle, versus a 2. So make sure your 2's are 2's and your z's are z's, because sometimes they sort of come together or change magically in the middle of the problem. Okay, we want to be careful about just being able to read your own handwriting. Well, It's all about trying to turn the complicated XYZ into a simpler system, something that has two variables. And if you look carefully, equation 1 and equation 3 look like the y's are opposites. Now, if you notice that, then add equation 1 and equation 3. Because if you make the y's cancel out, you'll be left with x, specifically 3x, and z, or again, specifically 2z. By the way, don't forget to add your constants. Again, that's a common place for mistakes to happen. But my point is that you now have one equation that has two variables. And of course, those two variables, once again, are x and z. But now what? And again, it's been my experience that this is where students have trouble realizing that we need to do this again. Do what again? We need to cancel y again. Now, that means you have to pick two other equations, not the same two, but two other equations where you can make the y's cancel out. I'm going to suggest that if you look at equation 2, okay, it could almost have an opposite y if it just had a negative 2y. But we can't just put a negative 2 there, or actually a 2, but we can multiply it by 2. Now, when you multiply by 2, you make a new equation. And you might notice here that I'm kind of giving a suggested organization technique. I'm not the most organized person, but notice that I'm kind of labeling my equations, and I'm also rewriting them. So equation 2a, the one that's been multiplied by 2, and equation 3, if I add those together, so if I add equation 2a and 3, if I add those together, I'm going to make the y's cancel out again. Okay, we like to have the y's cancel out because that leaves us with x and z, specifically 6x minus 5z, and of course it equals 14. So what did we do here? We made the letter y cancel twice because we had to, of course, make two equations. Now, these two equations have two variables, and that means you're back to yesterday. You're back to kind of basic algebra. I know you guys have done this type of thing, but let's still finish the problem. Let's make sure that you're good. When you look at this system, maybe you like to make the x's be opposites. Okay, some students say, let's make the x's be opposites and let's multiply by negative 2. And some students say, let's make the z's be opposites since they kind of already have a positive and a negative. I want to show that just because I want to make sure that you remember, which I believe you do, remember that you can multiply both equations by a different number. So if you'd like to use this method, you're going to end up with a new equation. Of course, everything's being multiplied by 5. What's 16 times 5? 80, right? That's kind of an interesting number there. And we're going to multiply everything by 2. So we're going to end up, with 12x minus 10z and 28. So we're on our way to solving a simpler system, but I did perhaps make it a little tricky because I decided to multiply both equations. But nonetheless, I'm going to end up with the ability to solve for x. Okay, it's going to come out, I believe, pretty nicely. It's going to come out to be x equals 4. Yeah, there's 4 27s and 108. And if you plug that back in to one of these x and z equations, you can find your z answer. And if you plug in x and z to the top equation, you can eventually find your y value. Once again, we end up with an ordered triplet, x, y, and z. Just a kind of a little side note here, nothing honestly that you have to try to draw on your notes, but do you realize that what we're actually doing when we solve a mega system with x, y, and z, what we're really doing is finding the intersection of three planes. Now, we're not talking about like an airplane, we're talking about a three-dimensional surface. It's actually a two-dimensional surface that's graphed in a three-dimensional space. So when you're graphing x, y, and z, and you're graphing three of them, you have three planes, three surfaces. Now, the most common way that three planes can intersect would be at a point, literally right here, where all planes are coming together. And this is what happened in our first two problems, and quite honestly, this is what's going to happen in all of our problems. But three planes don't always intersect at a point. Three planes could maybe not intersect. If they don't intersect, then there's no solution. We'd have like parallel planes. And you can see there's other ways that planes can intersect, and those things are a little bit more from Algebra 2. But this year, I just want to make sure that you are very good, that you are very excellent with solving one of these mega systems. So let's do one more. Let's find the intersection of these three planes. Normally, if we were doing this in class, I'd probably say, why don't you try this one on your own? I'm going to be honest, I'm going to show you, because there's still some things here that we probably need to hear and learn. First off, once you are done copying this system down, you notice it's kind of weird. Every equation seems to be missing a variable. Okay, so how are we going to approach this? Well, one thing I want to share, it may be something you want to do. You might say you don't want to do, but just to kind of organize this a bit, in other words, the variable that's missing, I'm going to leave like a space. I'm not going to write the number 0 in there, but I'm kind of organizing all my x, y's, and z's, organizing them into, again, kind of the same spots, basically the same columns. So it looks a little different when you write it this way, doesn't it? It's still the same system, but you kind of realize that you actually have three variables here. It's just that not all three of them show up at the same time. You're trying to produce two variable equations. Two variable equations. Just saying, all of these are two variable equations, right? All right, well, but I still need to do something to be able to end up with two that have the same two variables. All right, enough twos. Maybe you've already noticed that the y's in this pair, in this sort of system that I matched up, the y's would be opposites if I just make one of them negative. So I'm going to argue that we want to add these two equations together. So we add these two equations, and of course, what just happened? The y's canceled out. But maybe more importantly, notice that what do I have? Well, I have x and z. Now, x and z, I feel like I've heard those before. I've heard them up here. See, what I'm saying is I don't need to cancel again if I already have an equation that contains the same two variables. Okay, so I can take full advantage of the x and z, that is the 2x and 2z equals 2, that basically I was given. All right, so what do you think? Are you kind of back to, where you've been for quite a few of these problems? Basically, you're solving a simpler system. You're solving a two variable one. I don't normally finish this problem. Should we finish it in the video? Multiply by -2. We can kind of do that a little bit writing over top there, just to kind of show you that we're ready to find x equaling 4. Make sure after you find x equals 4 that you plug back into just this system. Don't go back up here to these yet. Okay, you got something you can work with to find your z value. Plug back in, you get z. At this point, I got to plug back into my original system because that's the only place where I can get y. So whether you want to plug into the second one or the third one, it actually does come out to be a fraction or a decimal. Just kind of want to share that, this is, it's okay to get a fraction or a decimal. It doesn't mean you did the problem wrong. All right, you gotta, it's your turn. You gotta get your fingers dirty, your hands dirty. You gotta start trying to do some of these, and that's what the homework's for. You can see that we have a group of problems, those are going to end up being kind of your simpler systems. Do them. You still want to do those, get them right. But to be honest, it's this group of problems, including number 38, that those are the mega systems. Those are the ones that now that you're in honors trig and pre-calc, that you want to try to work these out and get them right. Don't just copy the answer out of the back of the book, but work through it. Try to get yourself to cancel down to 2 variables, and of course you need 2 equations, and that'll get us moving right along here in Unit 7.